The final topic in our set theory unit is the topic of cardinality. Cardinality is the term for the number of elements in a particular set. So cardinality is when we're going to count how many items are in there. It's not so much about knowing what every specific one is as it is counting. So think about like taking a survey, a census, something like that. And the notation for that is n of, and then you put the set name. So we'll say like our set is set A. So n of A is how you read that. And the way I remember what it means is I think of n as the number of things in set A, or the number of things in set B. So let's look at a few examples. So for the sets that we've got there, A and B as defined, the cardinality of A, so n of A, is the number of elements in set A. Well, you can count them. There are 5. Part B, the cardinality, or the number of things in A union B. So first what we need to do is figure out what A union B happens to be. So that would be combining all of the elements of A, sorry I forgot the 4, with all the elements of B. We've already got the 2, the 4, the 5, and we need a 7. So that would be A union B. So the cardinality of A union B would be 6. There are 6 items in that set. Finally, the cardinality of B intersect A. So B intersect A is going to be the things that those two sets have in common, which is 2, 4, and 5. And so the cardinality of B intersect A is 3. Okay. So, moving on, using more of the idea of the descriptive method for describing a set. So what is the cardinality of set D, which is the set of days in a leap year? Well, the cardinality of set D would be the number of days in a leap year, which is 366. The cardinality of set E, how many even numbers there are from 0 to 20 inclusive. So the number of things in set E. If you go ahead and count those all up, don't forget we are counting 0. There will be 11. And if A is the set of consonants in the English alphabet, find n of A. Well, easiest thing to do is count the vowels. The vowels are A, E, I, O, U. There are 5 of those. 26 letters in the alphabet. Take away the 5 vowels. That leaves us with 21. All right. Now, looking at cardinality with a Venn diagram. So now I'm going to put numbers in the Venn diagram, and those are going to represent how many people in the survey belong in that portion of the Venn diagram. So we asked 240 people what they've used in the last week, Facebook or Snapchat. 175 said Snapchat, 85 said Facebook, and 30 said both. So I'm going to label these sets here. So this will be my Facebook and this will be my Snapchat set. Now, what you need to be careful of, very careful of, is if you just go throw in these numbers, okay? So if you said 175 said Snapchat, okay, I'll put them over here, and 85 said Facebook, and 30 said both, we have a problem because 240 people were surveyed. If you add these numbers together, we don't get 240. I don't know what we get. It's somewhere in the 300s, but it is not 240. That does not mean this information is wrong. It means we have interpreted that information incorrectly. Okay, so think about this. If I asked you if you had used Facebook and you would have raised your hand and I would have counted you. Same thing with Snapchat. And then I said, if you have used both, you would raise your hand again, even though you'd already answered you used them individually. In other words, these 30 people here, those people have been counted in both categories, Facebook and Snapchat. That's the intersection. Those 30 people belong here, okay? Now, remember, we've got 85 people saying they used Facebook. Facebook is this entire circle, the entire set. 30 people are already in there. We have 30 names, if you will, in that intersection. but another 55 of them had used Facebook but not Snapchat. They would be in that outer portion of the circle. And then 175 said they've used Snapchat. That's these people over here. 175 people. Now again, 30 of them have already been counted. They've used both. That means there have to be 145 people here. And now this is where we go and we look for these 240 teenagers. Now the question is, do 55 and 30 and 145 add up to 240? Okay, and I think you'll find that no, they don't. They add up to 230. So what happened to those other 10 people? Well, those other 10 people haven't used either one. They belong out there in the outside of the union of the sets. And so now we can go through and answer these questions. How many people use Facebook only? Well, that's those 55 people. How many people used Snapchat only? That's the 145. How many people use Facebook or Snapchat? So remember, that means one or the other, or potentially both. So that's the 55 and the 30 and the 145 added together for a total of 230 people. And then how many people used neither one? Well, those are the 10 people on the outside. So when you think about that, we could not just simply take the number of people in the union, that's part C, this 230, is that equal to the number of people who liked Facebook, the 85, plus the number of people that said they use Snapchat, the 175. Is that a true statement? Okay, no, you'll find out that's absolutely not true. Why is it not true? Because there's people that are being counted twice. Okay, so the people who used both Facebook and Snapchat were counted more than once. And so what do we need to do? If we just want to add up the people in the Facebook circle and the people in the Snapchat circle as circles, notice it's those 30 in the middle, these right here, that are the problem. If we don't want to count them twice, what we need to do is remove them once. So we can take the number of people who use Facebook and the number of people who use Snapchat and subtract the number of people who use both, which is the intersection. That will tell you the total number of people who use Facebook or Snapchat. This formula right here is going to come into play not only in this unit, but in the unit that we will be doing after this one. So that's an important formula.